All right. Hello, everyone. This is Daniel. I'm back again hosting the binding status after a great show by Marcus 2 weeks ago. So shout out to him for that. Looks like he's already in the chat and has volunteered to answer any questions or provide any context while I'm hosting the show this week. Let's see if we have anyone else who's joined. It looks like Javad is also on. Says there's a beautiful sunny fall morning in Seattle. That's good to hear. It is not the same here in St. Louis, Missouri, unfortunately. It's been very nice the past couple of days, but today it's gotten a little dreary again, so gonna have to deal with that. But at least we have the binding status to turn to. So anyway, it's great to be back with everyone again. As you join, please feel free to introduce yourself on the YouTube comments or in the TBS channel in Crossplane Slack, and I'll try to get to those as frequently as possible. Today we're just going to be going through sort of the picture that we're trying to paint for the 0.4 milestone, which is coming up here. So we'll have a release that's pretty quickly following our last release, which is based on some feedback that we got and we had internally about just wanting to have quicker releases and get features to end users faster. So you should be able to see more frequent releases happening, and we should be able to iterate a little bit quicker. So we're excited about that. We'll also take a look at something I've gotten the privilege to work on lately, which is adding a Rook stack. So if you're not familiar with Rook, it is basically a library of operators essentially to provision in-cluster storage in a Kubernetes cluster. And we want to be able to do that from Crossplane. So we're creating a kind of infrastructure provider that is Rook that allows you to provision in-cluster storage in any Kubernetes cluster. And we'll get into that a little bit. And that's kind of why the name of this episode is BYO Cluster. That's the name of an issue that we've had open on the repo for a while about wanting to be able to target any Kubernetes cluster, not just those provisioned by a Crossplane control cluster. So we'll get into that a little bit as well. I'll look back at the comments quickly here. Stephen, also on, joining from Florida. So we've got some good geographic diversity here. We've got, I believe, Marcus is in New Jersey, and we've got Javad in Seattle, Stephen in Florida, and I'm in St. Louis. So we just need to get kind of the I guess the southeast and maybe the north and south Midwest. We have most of it covered. So let's go ahead and get started here. Let me jump over to stream here. So, all right. So I probably should adopt something a little similar to how Marcus had his stream set up last week, but he's got some fancy video equipment, really just a green screen that I don't have. So I'll stick with mine. Although I did move the frame up here to the top corner, just so you could see a little bit more when I'm doing things on the command line. I got some feedback that it was kind of difficult to see that. So hopefully this will make it better. If not, feel free to let me know. I'll adjust accordingly. So anyway, I want to start off by taking a look at our roadmap. So if you jump over to the Crossplane repo, we have a roadmap MD, which is pretty common thing. And so we released 0.3 a while back, and got some coffee here. I may drink a little bit throughout the show here, if y'all don't mind. So over at the Crossplane website, we have a nice blog post that goes through kind of what the overview of the 0.3 release was, as well as a deep dive. And this is a series here. So Jared started off here. I believe Nick is going to have one coming as well. It's going to just kind of go through a little bit more in depth from a more technical perspective, how things changed in 0.3. So I encourage you to check this out. If you just come back to the blog post or follow the Crossplane Twitter account, you should be able to see those getting posted pretty regularly. And we're going to dive a little bit deeper into each individual stack. So our three main traditional stacks that we've had are AWS, GCP, and Azure, and just go through some of the updates to that, especially regarding secure connectivity. So jumping back over to the roadmap, this is all the things that we wanted to accomplish in 0.3, and we were pretty successful with that. We had kind of a late push, and we're able to get out some really good documentation that included both a services guide and a stacks guide for each provider. So as we move those different stacks out of tree, which we've covered on some previous episodes, into their own repos, we also developed a kind of stacks developer guide. Nick did a lot of work on that, so shout out to him to get that out there. And what it does is it allows any provider, any infrastructure provider, to build their own stack, as well as sort of application stacks, which we may touch on a little bit later. But I'll point out a couple of different infrastructure stacks that have been developing since this kind of change where stacks have been moved out of tree, and especially the Rook stack, which we'll take a look at today. So moving on to 0.4, we've got some broad categories here, and I'm going to jump over to the milestone in a minute, which gets a little more zoned in on specifically what we're trying to accomplish and has some issues associated with it. But we're making some improvements to the stack manager. So that's in terms of stack versioning and that sort of thing. So, you know, with the Kubernetes API, you usually follow a pattern of V1 Alpha 1, V1 Alpha 2, V1 Beta 1, et cetera, on up to V1 and then iterating on that. So now that the infrastructure stacks are out of tree, those are kind of versioned on their own cadence. And so we need a way to provide a good way to update existing stacks you have installed into a cross-plane control cluster that allows you to not have to, you know, completely uninstall your stack. So we'll be looking into that, and we should have support for that coming soon. Template app stacks. So this is just making the whole stack development process easier. So if we take a look over at the Crossplane IO org here, you'll see we have so like this sample stack WordPress, which is an application stack that allows you to create WordPress instances with a single CRD. So there's a fair amount of code here, but it's all pretty standardized in that you could generate this type of thing with some input parameters and that sort of thing. And so we want to get to a place where you essentially don't have to know how to write any Go code if you don't want to be able to create your own kind of application stack. And stack templates are really going to enable us to do that. And I'm sure on a future episode we'll probably get on one of the people on the Crossplane community team who are more involved with stacks to talk about specifically how that's implemented, what that's going to look like, and that should be a really great improvement for the community. I'm going to grab my coffee here and see if anyone has added any comments. Doesn't look like it. So we'll just keep going. So hopping back over here to the Crossplane repo, said we'd look into the milestones here. And that shows us a little bit more. So 0.4 is our next upcoming release. You'll see the due date is October 18th. So we're looking at the end of next week for this. So we have a couple of things that are kind of more repo organization, kind of community management sort of thing. So like the release pipeline here. But something that might be really good to look at is just our epics here. So if you go to labels and check out the epic label, these will be our broad issues, which will have reference to smaller feature issues. So these are really helpful. You can see most of these are in 0.4 or should be. So stacks versioning and upgrading, we talked about that a little bit. If you want a bit more of a deep dive here, you can look into this issue, see if any of the sub issues, check that out. Let's see, additional real world apps and scenarios. So this is something that we've all kind of been working on in order to kind of create a dog fooding situation where we're using Crossplane to host our own things and build projects on top of, and also invite other people to do that. That's something that template stacks will make a lot easier, just so we can start to get more rapid user feedback and also kind of be our own users, and see what kind of areas are pain points. And around that, we've already gotten some great feedback from the community, from a number of community members who give us some feedback about how we do claim to class binding. So in 0.3, in order to preserve portability of resource classes, we introduced what's called a portable class. And there's a fair amount on this over here at the Crossplane website. So if you want to get into the documentation, there is some stuff over in the services developer guide that talk about a non-portable resource class, a portable resource class. But essentially what was happening is you create a non-portable resource class in a namespace. So that would be something like a cloud memory store instance class. So something that's specific to a cloud provider, not portable across cloud providers. And then if you wanted to dynamically provision that, which means you're creating a claim that uses that class configuration to create that resource in the external provider, then you'd need to create a portable class first, which referenced a non-portable class, and it had to exist in the namespace of the claim. So essentially you have this layer of indirection, which allows you to publish, if you will, your resource classes, your non-portable resource classes, to an application namespace. And this is a really good model when you think about a large organization and how they may want to structure things. They may have a library of resource classes, a cloud memory store instance that's production grade, one that's experimental, that they want available to, some subset of their organization, that sort of thing. So they could essentially have a library of non-portable resource classes and then publish those to various application namespaces, where teams would be working to make those available, at different levels and that sort of thing. And so this is really nice. But if you're just getting started with Crossplane, this can be a bit confusing to have this layer of indirection. And it's a bit different than what we're modeled after, the Kubernetes persistent volume claims. So it can be a little bit confusing. So we wanted to help iron that out. So one thing that we'll be doing as part of 0.4, which we've talked about in Slack a little bit if you've seen it, and Nick has written up this proposal here, which is still under review, but should be getting merged pretty soon, that is basically eliminating the portable classes and allowing you to select the non-portable class using labels. So this is a little bit more consistent with the Kubernetes experience. This is a lot of times how pods are scheduled onto nodes and that sort of thing. So it shouldn't be unfamiliar or anything like that. And it also allows you to, once again, reference directly those non-portable resource classes if you would like to. The way we get around, having the different namespaces and that sort of thing, is still having a library of infrastructure classes, is that Nick has proposed that we have this select namespaces annotation, which you can put on a namespace that basically says, for this namespace, I'm also allowed to use these resource classes that are in experimental infra, as well as those that exist in my own. So this is a really powerful proposal here. I won't go through the whole thing, but I just wanted to point it out because I thought it was a really good example of getting some feedback from users and saying, how can we preserve this property of Crossplane that we think is really important, but also make this a simpler experience and kind of cater to both these audiences of new, maybe individual users or someone just trying out Crossplane, as well as a larger organization. How do we provide the right feature set to both of them at the same time? So I wanted to point that out quickly. Another thing that we will be working on during the 0.4 milestone, let me hop back over here to the epics label, is just making the APIs for all the different stacks a little more consistent, a little more updated, a little stronger, moving them to V1 Beta 1 So specifically, we're focusing on managed databases and caches. So Movafic is going to be owning that. And we can take a quick look over at this. And you can see on these individual repos, it has issues referenced on them that you can hop over to and kind of see exactly what they're outlining here. Movafic has also written up a great proposal that has been merged, and you can take a look at that kind of talks about what we think about managed resource patterns in general, so we can be a little bit more consistent across the infrastructure provider stacks. So a great place to find all of these kind of documents is here is either a one-pager or a design doc. So here we have Movafic's design doc, and it talks about everything from naming conventions, which some of this has actually already been implemented because Movafic's been moving really fast and making a lot of progress on that. Talks about how we represent the external resource name, talks about being high fidelity. A lot of things are interesting about this, about decisions about what goes into a spec or status. So if a resource can create sub-resources at the same time, so something I've personally worked on is Azure Virtual Networks. When you create an Azure Virtual Network with the Azure Go SDK, you can have some nested subnets in that. And do we want to be able to support those? Should those be represented as separate resources in the Kubernetes cross-plane ecosystem? Should that be a separate CRD, or can those be nested in that kind of parent resource? Those are all things that are addressed in this one pager here. So I'd really encourage people to take a look at that. And if you have any specific thoughts, then feel free to weigh in there. I'm going to hop over and check our comments here. Looks like we don't have anything new, and I'll look over in Slack quickly as well. Looks like Marcus put a message in there to the show. Thanks, Marcus. And great. All right. So let's go ahead and kind of move on to the thing that I think might have drawn some people to this stream today, and that was the mention of the Rook stack. So we're actually going to hop over to my GitHub account here. We're having some issues with GitHub that's not allowing us to create a repo that we want. So right now, stack-rook is living over in my repository, but it will be a little more official and imported into the Crossplane repo fairly soon. So I'm going to give a quick overview of Rook for those who may not be familiar. Rook is essentially a way to provision in-cluster storage in a Kubernetes cluster, and you can interact with that in the same manner that you would, something like an S3 bucket. So that would be object storage. It uses things like Ceph to be able to provision in an actual Kubernetes cluster, which is really powerful. And we definitely want to address that user community who is very fond of Rook and its capabilities, and we want them to be able to, provision a Ceph bucket, if you will, at the same time as an application resource if they want to provision their object storage in the Kubernetes cluster. So you'll see here a couple of the different types of storage that they provide. So in this release of Crossplane and this first release of stack-rook, then we're going to focus in on Cockroach and Yugabyte, mostly because those can be satisfied by our portable claims for a Postgres database. So usually when we have a claim for a Postgres database, we're going to have a resource class or something like a Cloud SQL instance on GCP or an RDS instance on AWS. We're going to provision that, get the connection information, and then connect to it from whatever application workload we're running in a Kubernetes cluster. But if you wanted to provision that database in your Kubernetes cluster, Rook allows you to do that, and we can kind of add all of these different capabilities just by supporting Rook. And Rook is a somewhat similar project crossplane in that it uses operators and custom resources to be able to do this. So it's provisioning things like persistent volume claims, pods that are running operators, that sort of thing, in your Kubernetes cluster. And from Crossplane, once we have stack-rook developed, then we are able to provision Rook resources, which then kind of provision these other resources in any target Kubernetes cluster. So one of the first things to enable this, which is something that's been added to Crossplane in the last week or so, is a Kubernetes provider type. So if we look over, let's take a look at stack GCP, for instance. This is true for any infrastructure stack. This one just happens to be at the top. But all of these infrastructure stacks have what we call a provider. And if you want to learn more about this, there's some more documentation, such as the provider part of the services guide here. And essentially what a provider is it just provides the necessary information to connect to an infrastructure provider. So what happens usually is you create a provider for your infrastructure provider, your cloud provider. And let's see here. I want to look at examples quickly and kind of show. So over in examples, we have this providers directory, which has GCP, AWS, Azure. And what it looks like is for GCP, for instance, you just get your GCP credentials, base64 encode them, store them in a Kubernetes secret and a resource type that's native to Kubernetes. And then you reference that Kubernetes secret from your GCP provider object. You also specify the project ID for GCP. And what that does is it allows you could potentially have a number of different providers for GCP with different accounts or projects, what have you. And then from any sort of resource that you want to target GCP with, so let's say we want a GCP MySQL instance, then we can reference that provider, and that will provision it with our credentials in the namespace that we desire. So as I said, the Rook is a little bit different because it's provisioning resources actually in a Kubernetes cluster. So our infrastructure provider is actually just a Kubernetes cluster. So this is not something that's, only unique to Rook, but it is kind of the first time we've encountered this within Crossplane. So recently we added a Kubernetes provider type, and this lives in core Crossplane because this isn't unique to any specific stack. So this can be used by any stack and that is Kubernetes native, and it looks very similar. It's basically just a Kubernetes provider that references a secret in the same namespace with a local object reference that has the necessary information to connect to a Kubernetes cluster. And if you want to read a little bit more about this and the design around it, once again, you can go to the design directory, and this one-pager Kate's native providers document. This is where it talks about the Kubernetes provider kind. Also in the show notes for this below in the YouTube stream, there should be a link directly to this. And the important thing that this enables, is the ability to bring your own cluster, essentially. So this is something that's been a feature request for quite some time. It's something that's been on the roadmap. I believe we have an issue from, in the 200s, which we're now in the 900s, almost 1,000 issues, that talks about wanting to be able to bring your own cluster. So right now, when you create or the only way that you can really access a Kubernetes cluster outside of the Crossplane control cluster. So you spun up a Kubernetes cluster. So let's say you're using Kind locally, or you're using Minikube or a cloud provider. You've created this Kubernetes cluster. You've installed Crossplane into it, and you start to provision resources. So the only way that you could talk to another Kubernetes cluster before the introduction of this Kubernetes provider was that you had an actual Kubernetes cluster resource, which we talk about a little bit in here with the Kubernetes application. And this is really valuable, but it means that you have to have a cluster that you provisioned with Crossplane, which cuts off a whole set of potential use cases because you may have an existing cluster you want to provision things into, and you can't do that because it wasn't provisioned with Crossplane. So this provider allows for 3 different scenarios. So you can use a Crossplane provisioned external cluster. So that's really simple because the Kubernetes cluster itself is going to propagate a secret, which is how it connects to the provisioned Kubernetes cluster. And then with the new Kubernetes provider kind, then you can just reference that same secret and then use that Kubernetes cluster as the infrastructure target. So this is something that was already enabled, but can look a little bit different now with this provider type. You can also do an existing external cluster. So this is the bring your own cluster kind of situation where you basically hand roll a secret that has any of the necessary information to connect to a Kubernetes cluster, and then you just create a provider that references that. This is actually what we're going to do today when we look at the Rook stack. I've got a GKE cluster that I've already provisioned, and it's already existing, and I want to deploy Rook resources on it, and I don't want to provision it using my Crossplane control cluster, which I'm going to spin up using kind. So this is a really valuable aspect right here that we can support now. Lastly, you can provision directly into your Crossplane control cluster, which is also very valuable. So before, if you wanted to, really the only Kubernetes type of native resource that we supported, it's a Crossplane native, but Kubernetes concept is this Kubernetes application. So the concept of Crossplane workloads. And right now, those can only be provisioned in a Kubernetes cluster that was provisioned using Crossplane. But with this, you could essentially just create a service count with the permissions you wanted, and then use the token from that and provision things directly into the same Kubernetes cluster that Crossplane is running in. All right, so I'm going to dive a little bit more into how this might change for the Kubernetes application type. But first, I'll check the comments here. All right, Marcus has some some complimentary comments here. Appreciate that. And yeah, it is really valuable that now we can bring any cluster to provision resources on. And I'm going to talk a bit about, which this actually came up today in Crossplane Slack, which we had a community member ask a really great question. It looks like their username is Ozota. I apologize if I'm not pronouncing that correctly. But they basically brought up the question of, is Crossplane going to be able to support bare metal K8s clusters, which yes, that definitely is a goal for us. And I want to show 2 issues we have open right now which talk about this and talk about how we're going to support provisioning Kubernetes applications on existing clusters. All right, so the first one, this is one I opened after implementing the Kubernetes provider. So right now, as I mentioned, to provision a Kubernetes application, you basically have to have a Kubernetes cluster that you created using Crossplane, that you provisioned using Crossplane, and it's scheduled to it using a label. And so if you have a Kubernetes cluster object that exists in Crossplane that has the app WordPress demo label, then this Kubernetes application, which specifies different kind of like workload components here, would be scheduled to it. However, that means that you do have to have a Kubernetes cluster object in Crossplane to be able to do that. So this issue here is proposing that we kind of swap that out and we use the Kubernetes provider kind, which then it would involve an extra step of, let's say if you did have a Kubernetes cluster that you provision using Crossplane, now you do have to create a provider for that. And then we could use labels or reference it directly using something like a provider ref to be able to do this. But it's an extra step, but it kind of opens up a whole nother set of possibilities, like using the Crossplane control cluster or an existing one, like a bare metal case cluster or something like that. So this is one way that we could do that. And I'm kind of in support of this. I think Muvafiq also pushed back on this a little bit, and I think he had some really good points about that this might be using in a provider in a way that is not really consistent with our definition of a provider. So I really appreciate him adding that back, and he kind of clarified on my response to that as well. So thanks, Muvafiq, and I think these are really important things to consider. To kind of summarize what Muvafiq's saying is, another way to do this would be doing this sort of import of Crossplane resources. So this is an issue that's been open for a little while, and essentially what it allows you to do is any existing resource on an infrastructure provider, you can import that into Crossplane and represent it with a custom resource. So Kubernetes cluster could fall into that. Let's say you have a existing GKE cluster, for example, and you want a representation of that in Crossplane, whether you want to be able to manage it or use other resources to reference it or something like that. We want to be able to import that, and you can kind of play this along in your head. If you're able to do that with the Kubernetes cluster, then we actually don't have to change anything about a Kubernetes application. We can still just schedule it to something that's represented as a Kubernetes cluster. So those are kind of the two main ways that at least I'm aware of that we may solve this problem. But it's definitely something that is not, it doesn't have a lot of technical complexity for the initial implementation, but it is just sort of a decision about design and patterns we want to support and what makes sense to end users. So if you are an end user or some sort of consumer of Crossplane, or just have an opinion and you're watching this, then we'd really appreciate your feedback on that. I know it's something that I'm excited personally about supporting, so I'd love for that to be the best experience. I think this is a big win for Crossplane users and definitely a big value play of Crossplane itself. So that being said, the Kubernetes provider right now can be used for Kubernetes native infrastructure providers like Rook. So I'm going to hop back over here to stack-rook demo, and we'll get started with actually looking through this a little bit. I'll check out the comments again to see if anything has come up here. Doesn't look like it. Once again, if you are just now joining the call, please feel free to introduce yourself, tell where you're tuning in from. All right, so let's get into stack-rook. So we talked a little bit about what Rook does. So it provisions in cluster storage. And so I have stack-rook open here. And we can kind of get a good feel of it by comparing and contrasting against other existing infrastructure stacks. So right now, all that this stack supports is the Yugabyte DB cluster. So you'll see here that where a lot of stack providers have under the APIs directory, they'll have just a v1 alpha 1 or whatever version they're on directory, which is where things like the provider will exist. Well, as we mentioned before, Rook's kind of like provider infrastructure is any Kubernetes cluster. And so it doesn't actually have to have a provider type because it's going to use this kind of shared Kubernetes provider that we've been discussing. So there is no provider type implemented here. So right now, all that's implemented is this Yugabyte cluster and Yugabyte cluster class, which allows for dynamic provisioning. So this is a little bit different than a traditional infrastructure provider in that what we're doing is we're basically saying, okay, we have our crossplane control cluster. This could also be the same cluster, but I'll explain it for simplicity with two separate clusters. So let's say we have our crossplane control cluster where we're running crossplane and we've installed Rook Stack, etc. This is probably something you may be familiar with if you watched the other TBS episodes or read some of the documentation. Just kind of our basic starting point. Then we have another cluster. Let's say it's on GKE because that's what we're going to use today. And on GKE, we've installed the Rook operators. So if we head over to the Rook documentation, we're going to do the quick start with Yugabyte DB here today. So essentially what you do is install an operator which provisions a pod in your Kubernetes cluster, which has the controller for Yugabyte cluster objects. And then you create a cluster CRD, which is a YB cluster type. So if we actually look over at the Rook repo here, then we can see exactly where this happens. So just like we have different custom resources, Rook has their own. And so if we look over, sorry, that was Cockroach. If we look over in Yugabyte here, we can see, well, the easiest place to see this is in the register file. But we can see that they basically have a YB cluster and YB cluster list. So this is just your typical kind of way that you provision a custom resource or create a custom resource in your Go code using controller runtime. So if we look over at the types, much like all of our custom resources, they have the YB cluster, which embeds a spec. And in the spec, they have different things embedded as well. So service spec, network spec, port spec. It's actually a pretty simple CRD, but the controller does a lot of provisioning behind the scenes, which we'll see momentarily. But it's a pretty cool setup. So essentially what we're doing from Crossplane, though, when we support Rook, is we are creating our own custom resource in the Crossplane cluster, and then that's using the controller for that resource is using the Kubernetes provider type to reach out to a target cluster. So in this case, our GKE cluster where Rook is installed, and it's creating a very similar CRD, but a Rook CRD for a Yugabyte cluster. So if you look closely at the spec here, and then it looks like we accidentally closed my editor here. See if it'll come back up for us. Here we go. Interesting. Looks like it updated. But if we look over at the Yugabyte type here, you'll see that we have a Yugabyte cluster spec, Yugabyte cluster, which embeds the spec. We also have a status, which is a little bit different from the Rook version of the CRD. But if we look at the spec, it's embedding our typical crossplane resource spec, which are these types that are common to all resources in any stack. So claim reference, non-portable class reference, which may be being removed with the new claim class proposal. Then we have a provider reference and reclaim policy. So these are probably things that you're familiar with if you've used Crossplane before, but they are imported from our Crossplane runtime library. And then we have this Yugabyte cluster parameters object, which if you look at this quickly, this looks very similar to the Rook Yugabyte spec, almost exactly the same. One difference is we have kind of provided our own representation of all of those specs, as you can see here, except for Rook annotations, which is imported. But we could also have our own implementation if we wanted to. So basically what happens is we have our Yugabyte cluster CRD wraps the Rook CRD entirely, and we have it kind of separated out by having this Yugabyte cluster parameters struct. And essentially what it does is our Crossplane Rook controller is going to watch for the creation of our Crossplane Rook Yugabyte cluster object. it's going to take the parameters specified on that, and then it's going to talk to that target cluster where Rook operators are deployed, and it's going to create a Rook Yugabyte cluster, and then Rook will have its operators create the necessary pods and that sort of thing accordingly. And then the reconciliation is basically from our cross-plane control cluster, we're going to look over into the Rook cluster and make sure that that cluster CRD over there is matching what we have. So there's also a number of different ways to do that, because since a lot of the logic for this is in the Rook operator for Yugabyte, we're not able to just look at the status of the CRD over in Rook for Yugabyte cluster. It actually doesn't have a status, as we saw earlier. So it's a little bit up for debate right now what we want to do to specify that an update or a change needs to be made, and to kind of monitor the health of that deployment, since the Rook version does not have a status that tells us the state of the cluster. But if we look over into the client package here, what we're doing is we have this new client function, which is going to return a Kubernetes client. So usually we return something like a GCP or an Azure client. Since this is a Kubernetes native provider, we're just going to return a Kubernetes client. So it takes in that secret, which it gets from the provider ref on the Yugabyte cluster object, and then it uses the information provided there to be able to talk to the target cluster. If we look specifically in the Yugabyte package here, this is a function that is basically taking our Yugabyte cluster representation in this cross-plane Rook stack and translating it to the Rook version of a YB cluster, which allows us to kind of have that translation layer. So what we could do is actually mirror that YB cluster exactly in crossplane, but that kind of ties us to the implementation there, and also removes a bit of the ability to have the status and reconcile things in the way that we do across crossplane. So having this simple translation seems to be a good pattern for us. If you have feedback on that, please feel free to give that. So you'll also see here we have claim and manage controllers. So this is like you'll see in any other infrastructure stack. The claim one here have a bit of stuff kind of left over from copying, and don't actually do much spec provisioning here. But essentially what this is doing is just creating with a Postgres claim, you can reference a Yugabyte cluster class, a crossplane Rook Yugabyte cluster class, and then you can dynamically provision it just like you would a Cloud SQL instance or an RDS instance or something of that nature. We're actually just going to do static provisioning today just because it's a little bit simpler. In our connect function, what we're doing is we're getting the provider ref of the crossplane Rook Yugabyte cluster, which is it's in the spec, and then we're getting the secret that references it, which has the Kubernetes information. And I know this is kind of a lot, but we'll actually show an example here in just a moment. We'll get that secret, we'll create the Kubernetes client from it, be able to talk to that cluster, and then we'll implement our manage reconciler functions like observe, create, delete, update. And instead of reaching out to GCP or AWS, what we're doing is reaching out to another Kubernetes cluster, or it could be the same Kubernetes cluster you're in, depending on how you're provisioning. And we're looking at the status of that CRD in another cluster, as opposed to asking GCP what the status of our Cloud SQL instances. So in some ways, this is a lot easier because it's kind of like we're talking the same language, right? It's a lot easier to compare the spec of two Kubernetes objects than it is to kind of like reconcile the status of a Cloud SQL instance to a Cloud SQL instance object in Crossplane. So this looks pretty similar here. You'll see some comments, but overall it looks pretty similar to others. We look it up, we create, delete, etc. Have another drink here and see if I can see if there's been any comments. Oops, sorry about that. Doesn't look like any new comments. All right. So let's get back to the actual demo here. So I'm pretty excited about this. I was just working on it this week and kind of got it to a state that seemed ready. Wasn't really planning on doing this for this episode, but since we have kind of a ready demonstration, I thought it'd be useful to present it earlier and potentially get some feedback on it a bit earlier in the cycle. So I've got four terminal tabs open here. Basically, in these two on the right, I have my kube control configured to talk to a GKE Kubernetes cluster that I provisioned. So this is just the bare bones what GKE gives you when you first configure a cluster. And then in these two, I don't think I have anything set up right now. I hope not. It should give me an error here. Yeah. Okay. So what I'm going to do here is create a local cluster using Kind. Shout out to everyone who works on Kind. That's made testing and local development a lot easier. So really appreciate that. Some good folks over in the Kubernetes community. So let's go ahead and get started. And with this local Kind cluster, I'm going to call cross-rook, which I was using for testing, which I think is kind of a fun name. In this local Kubernetes cluster, this is going to be our cross-plane control plane and our control cluster. And so what we're going to do here is install crossplane. We'll use the latest master version so we can take advantage of this Kubernetes provider type. So you can go through the docs and kind of see how to do this. I'll bring that up actually quickly while we're waiting. So yeah, over in the crossplane docs, you can do a simple installation here. We're actually going to follow this. I'll just copy and paste from here for brevity and to show. So we're going to use the master branch of crossplane, so the most recent published version. And so let's do so here. Well, actually, one thing that I neglected is we're going to need to install Tiller. To do so, because we're using Helm to install the latest crossplane master branch here. So this will take just a moment. Oh, sorry about that. Copy paste error. All right, so we created that cluster role binding, basically giving Tiller admin access, which everyone loves that we have to do that. I know. All right, so that Tiller deployment's gonna be rolling out here. It's creating the container there. All right, and once that's done, looks like we're good on that. Once that's done, we can go ahead and add crossplane. So as you see here, we've got the alpha version, which is 0.3, our most recent release, but we're going to use master so we can take advantage of that Kubernetes provider type. So I will do that here. And the version we're going to get from here. And this is going to install crossplane and also all the CRDs. So as you'll see here, we've got that provider.kubernetes kind, which allows us to create Kubernetes providers that we went through earlier. And right now I'm in the stack-rook cluster examples here. So, and you can do this as well. I've pushed this up to GitHub. So in my secrets directory here, I have these three files. So in order to connect to a GKE cluster, you basically just need a minimum of token, endpoint, and certificate authority. So I've got the cert, endpoint, and token in plain text in those files. So I'm going to base64 encode those and then replace them in the secret here and create a Kubernetes provider type to reference that in this rook infradev namespace. So importantly, we haven't done anything with rook yet. We're just using core crossplane things right here. So I can go ahead and provider.sh. I don't have the rook stack running or anything like that. So looks like all those things were created successfully for us. Also, if we want to look and see, if you're not familiar with crossplane, we basically have this core crossplane pod running here that has the controllers for things like the default class and Kubernetes application workloads and that sort of thing. And then we also have the crossplane stack manager. So what we've done here is we've said, I'm going to want to connect to this Kubernetes cluster that's running on GKE. I've given the credentials to do so. I've created a provider. So now anything that comes along and wants to reference that provider to connect to the cluster, then they can do that. And I did this beforehand just for it to be a little simpler. Well, let's see. I have a service account here. This default service account is actually what we're using, and I've given it cluster admin privileges and then use the token to be able to connect to this cluster. So, you know, a nice thing about this provider type is you can kind of specify any kind of connection to a Kubernetes cluster that you want. So you can restrict those permissions as much as you want. You likely do not want to give admin privileges for every Kubernetes provider type you create, but it is nice that that's kind of like an option to do that however you like. So what we want to do next is install the rook operator and rook cluster. Well, we'll start with just the operator. So the rook Yugabyte operator, we want to install that into our GKE cluster. That's going to be our target where we're going to run rook as our infrastructure provider. So as you can see in this cluster examples, Kubernetes Yugabyte DB directory. So once again, these two tabs here are in my rook directory, and these two over here are in my stack-rook directory. So these two you can think of as crossplane world, and these two you can think of as rook world, and my GKE cluster and my local kind cluster. And I've got the kube control set up in each of these to talk to their respective clusters. So you can see here, this is where crossplane is running. Over here, we've got, let's see. We've just got our GKE default stuff running. Excuse me. So let's get started. Like we saw in the rook docs, we have this operator here. All we have to do is install that to get going. Oops. And this will install our rook operator here. So you can see it creates a number of things here. We're not going to go into exactly what all rook does here, but you can see sort of some similar things we're familiar with. It's installing this CRD for Yugabyte. It's installing, or it's creating a cluster role, service count, cluster role binding, etc., things that are used by operators to orchestrate things within Kubernetes. And if we get the pause again, we're now going to see this rook Yugabyte DB operator. So now we're able to provision rook Yugabyte resources in our GKE cluster. And I'm going to start off by actually just doing this directly. So you can pretend crossplane does not exist for this part of it. Essentially what we're going to do is just be able to provision a Yugabyte DB cluster in this GKE cluster using rook. And all we have to do that is use this example that they've provided to us, and so you can see that it creates this custom resource. And if we look at this, you can see all of these pods starting up here. if we want to see everything that it creates, then we can just look in this rook Yugabyte DB namespace. You can see we've got some services, some stateful sets. Looks like stuff is still coming up, so we'll wait for it to come up. One thing that I think is really cool is Yugabyte has a nice dashboard, which we can look at. So I actually opened a PR the other day to Rook, very small, it's probably annoying, to add this to the docs, just because I think it's really cool to be able to do this and immediately see the dashboard. So I've got this PR open here, which basically just shows you how to port forward in Kubernetes. So I'm not doing anything revolutionary, but basically, if we look at the services, we'll see that this UI is exposed via this service. So if we look back over here and let's see if everything's done creating here. Yeah, that looks like it. We'll see we have this master UI hello YBDB cluster that exposes the UI on port 7000. So if we just forward that to our local host, then we can hop over to localhost 7000 and take a look at our cluster. So here it is. You can see we have our master nodes here. So if you look at that YB master hello YBDB cluster 1, we can look back over here and there it is. So it's pretty cool. Rook is awesome. There's a lot of people who are big fans of it, as I am myself. And so definitely something we want to be able to support using Crossplane. So now let's jump in to how we're going to do that. All right. So I'm going to stop port forwarding, and I'm going to delete this cluster we created. And you'll see what it's going to do here is basically terminate these pods. So it's almost done here. And this will finish out in just a moment. There we go. I can't remember if it... Let's see. I want to briefly look and see here if we need to have the namespace existing beforehand. Yeah, I'm going to go ahead and create that Rook Yugabyte DB namespace. Although I'm not sure if it'll automatically provision or not, but we'll just have it just in case. All right. So we can see that exists. All right, so now we want to do the same thing, but using Crossplane from our Crossplane control cluster. So maybe we have a bunch of different Rook clusters that are out there that we want to provision resources to, and we want to provision them alongside our Kubernetes application workloads and maybe even some cloud provider resources themselves. So first thing I'm going to do here is install these CRDs that we have for Rook. So like I said, we only support Yugabyte here in this example demo. So if we look in CRD, we're going to see Yugabyte cluster classes and Yugabyte clusters. So in order to be able to create those in our Crossplane control cluster, we need to install them. So that's in config CRD. So I'm just going to add these custom resources to the Kubernetes cluster, our kind cluster here. So those are created. And now what we can do is, I'm going to run this with the debug flag, but we can run the root controller locally. So it'll get started up here in just a minute. Here we see it starting these various controllers and workers, the metric server. So now what we want to be able to do is we've already created our provider, and so we want to be able to create a gigabyte cluster. So right now, the way this is designed is it's going to create the gigabyte cluster using the spec we have here, using that cross to rook translate function that I pointed out earlier. And it's going to create it in with the same name and namespace that we have a local crossplane cluster. One thing that we make our crossplane Kubernetes cluster and then a different one in our target one. It's my opinion we probably do want to support that, but right now we're just going to do it in the same name and namespace, and that would be a pretty simple fix to be able to make that happen. So this is actually the exact same configuration from here to here as we had for our Rook gigabyte cluster that we just provisioned. And you'll see that we have these kind of embedded types, though, that these embedded fields that are part of Crossplane runtime that are common to every managed resource. So we're referencing that Kubernetes provider we created earlier, and we're specifying the reclaim policies delete, which simply means when we delete this managed resource in Crossplane, we also want to delete the external one, which we'll actually see that functionality here. After I create this and delete it, it will delete the corresponding custom resource gigabyte cluster in the target. So we can get started by, and we have our stack-rook controller running over here. So we've already created our provider, and so now we can create our cluster. Maybe. Oh, gigabyte is what I called it. Naming is easy. All right, so we are going to create this gigabyte cluster. So once again, we have, before we do this, we have our Rook gigabyte operator running here, but we don't have any gigabyte cluster provisioned. So we'll create it here. You'll see it being reconciled. And let's see if we can get the status here. So it looks like it's available for use and it's been successfully reconciled. So let's hop over to here. And what we want to see is that essentially those same pods that were created when we created the gigabyte cluster directly in the Rook cluster, that those have been created using Crossplane from another cluster. And what we see here is that is the case. And let's once again, well, actually, we'll do it over here. Let's see, I want to get all again. So we have these pods running again. And once again, it's serving the UI on port 7000. So I'm going to port forward that again just to show that we've spun up a gigabyte cluster using Crossplane. So we've spun it up in a different cluster, which is pretty awesome. And here it is. So we have that same cluster here. And we provisioned it the exact same way, so it's going to look the same. We might should have called it something different so you could see the change, but you can take my word for it. But yeah, so we've been able to do that, and let's see if we're able to now clean it up. So we created it, and now we're going to delete it. And what it should do, oh, that's not what I meant to do. Yep, so all of those pods are now gone. And you'll see that we finished the deletion process here. So we were able to create and delete a gigabyte cluster in a separate Kubernetes cluster where the Rook operator is running. So like I said, there's a couple of areas in this Rook stack that we probably will need to iterate on and we'd like feedback on, especially from members of the Rook community, because we know that you have very valuable insight. We're fortunate enough to have a number of very integral Rook team members on the Crossplane team as well. So that's been extremely helpful to have their insight. I actually came to Crossplane before Rook, even though it existed prior. So I don't have as much context, but I can see the value in it, obviously. and the ability to provision Kubernetes application resources on a on-prem cluster or something like that, with provisioning storage in the cluster alongside it as well, or potentially using in-cluster storage for one aspect of it, maybe object storage, and then using a managed database on GCP, and provisioning all of that together is really powerful functionality. So we're really excited about that. And 0.4 is going to have some really cool stuff. And I think we're going to have some cool stuff to show off at KubeCon. So if you're going to be there, make sure to come find our booth. And I think that's everything that I was planning on covering today. I guess it was kind of a lot. I'm going to see if there's any comments here. So, looks like my chat may have broken down here. Let's see if this helps. Looks like we might have had some visitors from Yugabyte DB Slack. So that's really awesome. Welcome to everyone. If you have any feedback, which I'm sure you'd be a great group to ask for feedback from, then I'd love to hear that as well. But yeah, that pretty much covers everything we wanted to get to today. Some of those epics that I mentioned earlier, feel free to continue to monitor those, give feedback directly on them or on their sub-issues. We've got a number of design documents open, so feel free to monitor some of those. And without further ado, that's the binding status for this week. Thanks for joining us. I'll make sure to put up some extra show notes in the TBS repo here, which is in the Crossplane org, and we keep all of our information. So maybe I'll put up a little bit of stuff from our demo as well, or at least a link to the stack-rook. So I'll make sure to add that here in TBS 4. All right, so that's all I've got for the day. Hope everyone has a wonderful Thursday and a good Friday and weekend. Thanks for tuning in.